So we solved this exponential equation, and we got x is this value down here. Now I want to check this. I want to check my answer. So first thing I need to do is I want to calculate this as a decimal value, and then I'm going to take that decimal value and plug it back into this equation and see if it works. So we'll start with checking the decimal value. Now you've got one of two possibilities. Either you can use parentheses carefully, or you can use a little trick with fractions to write this in a little bit more natural way. Let's go with the higher tech version. This is going to work on your TI-84, and TI-84 color. If you hit the alpha key, then the y equals key, you're going to get a menu of different options. And the first one there, if you just press the enter key, allows you to write a fraction. So that's what I want. I want -1 plus ln of 19. It's a good habit just to close off the parenthesis. Every left parenthesis deserves a right parenthesis. Divided by 4. Don't hit the enter key yet. Hit the right arrow. And once you have that entered, we're going to store that. So stow in x. You should be able to get something like that. Now, if you don't have this nice feature of being able to do the fractions, then what you would have to do is you'd have to do the same thing with parentheses. -1 plus ln of 19, 2 sets of closing parentheses, 2 right parentheses, and then divide by 4. And notice I get the same thing. But your value x this value 0.486 is stored in x now. And that's our solution. So here's what I propose to do. I'm just going to type in the left-hand side of this equation, and with this value of x stored here, I should get 20. So let's do that. 1 plus second ln. Second ln takes me to the e function of 4x plus 1. And when I press the enter key, what should I get? 20. Bam. Nailed it. So that's one way to check your solution. And I promised you another way. Let's look at the other way. Are we good with the first way? Checking it that way? That one worked out pretty nice. That's a nice approach. Let's check it a different way. If you hit the y equals key, then we can check it a different way. Let's type in this equation for y1. So I'll put 1 plus second ln, which gives me my e, to the 4x plus 1. So that's going to be one value for y, or one equation for y. And the second one is going to be y equals 20. And that's good. Before I graph this, I need to set up my window. So let me give a little bit of help here on this one. Let's see. Let's set our window up from, say, -2 to 4 on the x-axis, and on the y-axis from, say, -2 to 25. Let's make the step size 5. That is y scale. It's going to be 5. I don't want to overcrowd my y-axis with a bunch of tick marks. And you should see two graphs. One's characteristic exponential function, grows really, really quickly. The other one's just a constant graph right there. My solution to this equation is where these two graphs cross each other. And so you can find their intersection. So second calc, and the fifth option down is your intersection. What your calculator is going to ask you for is to kind of get close to your intersection. Let's see, first curve. I'm not seeing where I am. There we go. There. So just kind of get close to the intersection and press enter for the first curve, second curve, and then the initial guess. Just press enter 3 times. And you should get, for your x coordinate of the intersection, the solution that we just got, 0.486. So it's a different way to work these types of problems. In fact, we're going to do this with problem number 70 in just a minute. So are we okay with that little trick? because like I said, we are going to use that. Let's go back and help out Mike here. He was a little unhappy that I didn't give a numerical solution. It wasn't solved until we had some numbers here. So coming back here to this one, you're going to need 1 plus log base 3 of 5 over 2. So again, it's handy to have that little number key, that little trick that allows us to do fractions. So I'm going to hit the alpha key, y equals, first option down, and do 1 plus. Now I need log base 3 of 5. Well, you can get that from a couple ways. Some people like to do it off the math menu. I do it from the window menu. Either way it works. Let's go to the math menu. It's the very bottom one down. Well, second to bottom one. Log base. And when you press that, that allows you to do log base 3, and then the upper right arrow to the 5, divided by 2. Bam. So that's our numerical solution. It was about 1.232. And you can check that much in the same way we checked our other one. You can store that number into X and then type in your equation. Yes, sir. I just chose to round it to 3 decimal places. I could ask for anything. The problem asks for 6 decimal places. Someplace in the book they wanted 6 decimal places, which I thought was even a little bit extreme by my standards. And I know I'm already extreme. So now, what if you don't have a calculator that does log base 3 of 5 like that for you? Then you've got to use the change of base formula. So log base 3 of 5 would be log of 5 divided by log of 3. So that's your change of base formula. Let me show you how to do it with this. I'm first going to start out by just calculating log base 3 of 5. So it'd be log of 5, right parenthesis, divided by log of 3. All right, so I get that. Then what? Then I need to add 1 to that. So let's just do plus 1, and then press the Enter key. Now I've got the sum in the numerator, and I'll divide by 2. And at each step, I'm using the fact that your calculator keeps along the previous running total or answer, and it'll just do what I want. So it divides that by 2, and again, I'm getting the same exact answer. So a couple nice tricks for you in terms of how to work through your graphing calculator. Yes, sir?
Would you then test to see if that make the even fraction with that on the calculator?
Oh, this won't be a fraction. Yeah, if you hit the math key, answer a fraction. I do like fractions when you can get them, but you know, with logs and radicals, it's not very often you can get fractions. But I can store this in X and test it out. I should be able to do 3 raised to the 2x minus 1, and when I put that in, I should get a 5. So let's see. Bam, nailed it. All right. Any final thoughts on the graphing calculator tricks here? Okay, we're all set then.